Hello, everyone. So my name is Yelena. I'm one graduate. I'm one of the graduate faculties here at the data analytics program. The purpose of tonight's session is to help you get started with R and with RStudio that you're going to be using in this course. So here is the agenda for tonight. We're going to talk about what R is and what RStudio is. We're going to talk about the RStudio environment and its interface. We're gonna talk about how to read data from the CSV file into R. We're gonna talk about the data frame properties. We'll talk about row filters, adding, deleting variables, and more in data visualization. So we have a long agenda for tonight. So now this is the data that we're gonna use for the illustration purposes. The data tracks the employee satisfaction, job satisfaction level when the last evaluation was made, number of projects that the person was on, average monthly hours, and etc. And the purpose of this data is to predict if an employee left or remained in the company, right? So here is the data that we're gonna use today for the demonstration purposes. All right, so now all of you have been talking about now R. What is R? R is a language for statistical analysis and data visualization. It's free and it's an open source, right? And it's available for different operating system and it's platform independent. So basically, if you're using a Mac, you can download R, and if you're a Windows user, you can also download R. Now, you may save the commands to the script to be able to reproduce the results later on. The results can be your results, and as well as the code can be shared with others. There is a very helpful online documentation, and the language is continuously growing. It works well in academic environment, which is what we're doing, right? Then you have more than one way to produce the same result. Then R supports the parallel processing, but of course, we know that there are some drawbacks. There is no graphical interface for R. It requires some effort, and there is some learning curve to learn it. Then the language, R language is case sensitive. It will not solve all issues, right, that you're trying to solve. Then you cannot embed it into web applications because it lacks basic security. So that just, and just keep in mind, it's slower than Python and Java, just some drawbacks, right? Now, what you need to install, first of all, you have to install, well, I recommend installing the latest R version. And you want to, here is the URL for Windows and here is the URL for Mac. Well, I recommend the latest because first of all, your last assignment is going to be the group one. So it helps when everybody is using the same version, right? And also because some of the latest libraries that will need to be installed, you need to be installed and work only in the latest version. So, but if you have an older version installed already on your PC, well, it's up to you. I keep on updating mine at all times. So now what is this? What you see here, this is a basic interface, right? And I'm gonna start, I'm gonna work straight from the RStudio. It might be easier that way. But first, okay, so you're gonna install R and you're gonna install RStudio, right? So know that, but when you install R by itself, right? R does not have any graphical interface, but RStudio does have some, limited, but it does have some, right? So now, so here is how RStudio looks like. There are 4 panels, but when you start it first, you're gonna see 3. When you first started, you're gonna see 3 like this, right? So what is this? This is a console window. That's a window where you may type the commands in here, and all your outputs, when you run the command, all your output will appear in this console window. Output, then there also could be error messages, warnings, right? And etc. All your messages gonna appear in the console window. At the top here, at the top right, what you see is environment window. At the moment, that window is empty because you have not started, you have not run any code, but usually it will show any objects that are right now in memory, right? Any objects that are currently in memory, are gonna display in the environment window. History is a history of the commands that you ran recently. So here is my history, for example. And if I want to rerun the command from the history, I can click on it, and then I click on it to console, and I'm gonna click enter, right? So doing so will rerun the command from the history, right? So now what else do I have in here? In here you have several panels. Files panel is going to show you the files that you have in a current working directory. Working directory is a location where R is going to look at by default. When you attempt to load data or when you attempt to save the file, that's a place where it's going to try to get it by default. Plots, it's an area where you're going to see visualizations. At the moment, we don't have anything, right? Packages. Our functionality is is split into the libraries, if you will, right? So what's a package? Package, it's a collection of the code, and it contains as well data and something that's it's called VNet, right? It's a PDF file with some examples of how the functions and the packages could be used, right? Some packages contain VNet, some packages don't. And also nice help pages, right? So what else do you see here? This is a help system. R has an excellent help system, and I will show you how to use that. And don't worry about these two tabs, okay? Now, I'm gonna go back to the slides. Mostly I'll be using actually running the commands, and I'll show you. Now here, R script. So what is R script? To make sure that all the work you're doing is reproducible, you want to save your commands in a file. Well, of course, you can run the commands one at a time in the console window, that's fine, but the problem is your code will not be reproducible. Well, the idea is if I stop working in the middle of it, tomorrow when I return, I should be able to go back to where I am. Another thing is that there is no undo. So if you made a change to our code, you cannot undo it. One thing that you could do is to rerun the code from the beginning, right? You read the data again and you reproduce the work to where you started, right? To where you stopped. So now, what is a source file? So look at this. For your assignments, you'll do this. You're going to go File, New File, and you're going to select R script. This opens up the source window, right? This is where you're going to type the code, and then you're going to save the file with the code, right? Like for example, I'm typing the command version, right? Okay, then I can type the command something like this, right? Right? So this one, the question mark is just going to give me the help page for this command. And then I want my work to be reproducible. So what I'll just do, I'll go in here and I go File, and I'm just going to go Save, and I'm going to save my R code, right? Whatever that is. Or you can also, if you know that you have the file already saved, right? You can do Open File, and then you find where you saved your file, right? But I'm going to show you a little cheat sheet in here. I'm going to show you a little shortcut. Look at this. Okay, first of all, let's close it. Don't save. So look at this. Suppose that you just say you saved your file, but you don't remember where you saved it. Look at this. You have this here, file, recent file, and this is the introduction to R file. This is the file that I prepared for you for tonight's demo. Okay, so after this session, you're going to receive a copy of the slides, and you're also going to receive this file that I created for you, and we're going to look at these commands. Okay, so, and I'll show you how to run the script. So first of all, take a look at this. What is this here? This is called a comment. Comment describes what the code does. It's a non-executable line of code, right? So this thing, it starts with a hash. So this is a comment. Like for example, here, this section, I just put it here. So the code that follows is about our environment and its variables, right? So now here we're going to discuss what these commands do. The R version or version command, they're going to return the R versions that you are currently running on your PC, right? So in my case, I'm running the latest. Session information gives you, it also gives you the R version, but in addition to that, it gives you some information on your operating system. So as you can see that, right? I'm using Windows and so much more right here. So here, these are the packages that are in memory. See the statistics, graphics, devices, utilities, data sets, method, and the base. So whenever you start R, certain packages, right, are in memory. What's a package? Package is the set of functions, if you will, right? Like, for example, one of the packages that is in memory is a data sets, right? And R and that data sets package, right? It contains the iris data set that you are asked to use for your first exercise, right? So that data set is in the data set package. Just knows it, right? When I launched R, some of these packages are in memory. See this base, right? And this is a data set, right? So now here, this command is going to display the time. This will show what you currently have in memory. At the moment, I don't have anything because I have not done anything, right? But in other words, ls is going to show you what you would see in this window. Object is an alternative way to show what you have in memory right now. I don't, right? Data is going to show me the list of data sets that I currently have available. Those are the data sets that are pre-installed. So in other words, when you installed R, they were installed with it. See this is a package called datasets, and this is the datasets that are available, and also they are in memory right now. Not all packages are loaded in memory. Look at this. If you see the check mark next to the package, it means that it's available, it's loaded in memory. If it's not, then it's not loaded in memory, right? So just know that. And we're going to talk more about packages. Now, you may use R as a calculator. Like, for example, I run the command 5 plus 9, right? And what else? What do I do to run the command? I click on the command and I click run, right? That's how I do it. Now, see this? It shows 14, but what else is here? Well, note that R is a vector. R output is a vector. So here you have a vector of single element, right? And the element is number 14. See this? It's a vector, and number 1 means that it's a position of the first element. Remember that the element numbering starts from 1 in R. In Python, remember it's from 0. In R, we are starting from 1. Now here, this will just print, welcome to data mining. It's just gonna print this sentence here, right? So now note here, I did 5 plus 9, but I still don't have anything in my environment because I did not assign it to anything, right? What I'm doing here is I'm creating new variable x. And what is this? This is an assignment operator, right? So I'm assigning 3 to an x, okay? So let's see here, let's see what happens. I'm gonna run it, but I don't see the output because I never say to print an output. One way to do it is just put an X, right? You just type an X and it's gonna return what X is. Remember, everything is in R is a vector. So here, this is just one element and the value is 3. Suppose that I want to take a shortcut. I want to create Y and I want to assign 5 to a Y, and I also want to output what Y is. So what I can do is I can net the operation. So this is, I put this in parentheses, and you're just gonna click here, right? So it's gonna show what? It created Y, and it assigned 5 to a Y, okay? Now, suppose that I've been working for some time, and I might have a lot of columns that I no longer need, right? A lot of variables, right, that I no longer need in here. So what you can do is, there is a command called rm, and rm command is going to remove the variable from the memory. So you specify the variable names that you want to remove, you run rm. So here's no more x. Y is still here, X is removed. Now, suppose that I have 1000 of this here. What am I gonna do? Am I going to run the command for one at a time? No. But instead, what am I going to do? RM can take a list as an input, right? Because what is ls? Ls is going to return what? A list of variables in the environment. But if I take that and pass it as a parameter to RM, it's going to remove everything that I have in my environment right now. So let me run this. See this? I don't have anything in my environment. Another command here is options. It's going to show you the options that we have. Like, for example, what is a timeout, or suppose the output is super long, how many characters of the output do you want to see, and etc. There are many options. Here, this is how you clear the screen. It's similar to the control L, yeah. But this is how you clear this console window programmatically. You just type that. Div off is just to clear the plots. I don't have plots at the moment. History 5, it's going to show me the last 5 commands from the history, right? I see the last 5 commands here. Now, remember I told you everything is a vector, right? So now suppose that I want to create a vector of the elements of 1 through 5, right? But I don't want to assign it to anything yet. I just want to output. I use the command is called combine. C is a combine command that creates a vector. But at the moment, I'm not storing it, right? So this will just output the vector of 5 elements, right? 1 through 5. But here, again, it says 1 because the first element is at position 1, the first element in this row. Okay? Now, I did not assign it to anything, right? An alternative way to create a vector of elements 1 through 5 is to put 1 column 5. So this is a shortcut, right? Instead of listing 1, 2, 3, 4, 5, I can do this. But in this case right now, let's assign it to an X, right? This time I'm going to assign it to an X. And when I'm output an X, I'm going to see that. See, so this is my X. But suppose that my X was 1000 elements long, right? Just for example, and I wanted to see only the third element. I don't need to output the entire, right, X. I don't need to display all values. I can just specify the position of an element that I want to see, right? So this is the third one, right? So what this will do is it will show the third element. See this? That's what it does. Now, class is going to show the data type. So this is a vector of numbers, right? Integer, okay? And type of it the same. Sometimes it's a good idea to see multiple ways to do the same command because you're going to see it done multiple ways depending on the region you're looking at, right? So str command is going to show the structure. In this case, it's just a vector, right? Nothing fancy. Now here, in this case, suppose that I want to create another vector, right? I use the combine command, but in this time, I want to have elements 1 through 5, and then I want to have 8 through 10. So this is another way. Instead of listing 1, 2, 3, 4, 5, 8, 9, 10, I can do this 1 through 5, comma, 8 through 10, right? And then I can output y, right? So let's run this. This is a y and output y, okay? Here, if I want to see just the subset of y, elements at the position 3 through 6, I can do that, right? Now this will just specify the positions of elements that I want to see. Class y is just going to show the data type, and str is going to show the structure. Now, do you see that? What you could do also here, you can, this multiplication will multiply every element of y by 2, right? And then we're going to see what y is now. It's multiplied by 2. You may also create a sequence if you like. What this will do, it will create the sequence of 10 elements starting from 1, and the increment is 1, right? So let's see what it does. Yep, see this? You've got 10 elements and you started from 1. Well, starting from 1 is by default because I didn't specify what I wanted to start from, right? On the other hand, here, I can specify that I want to have a sequence of elements, and I want to start from 2 and I want to end at 2, right? So I'm starting from 2, ending at 10, and increment by default is going to be a 1. 1 is the default, right? So that's it, and I'm going to display that. That's what it is. And here I just want to add more. I want to increment by 2. So it's going to be like 2, 4, 6, and then output. Okay. Well, this may sound simple, but it's used as part of the bigger commands. So that's why we're going over it. Then earlier I mentioned that R has excellent help system. So how do we use it? You can type the word help, and then in parentheses you specify the command that you need the help for, or you can just put a question mark and put a command name. Okay, now here you can just do this. Now suppose that I'm looking for something and I don't know how to spell it right, but I know that it contains BIR, right? So I use a propose command, right? And it's going to look for the list of possible commands that I could be looking at, and that contain BIR. So let me see. See this? So this gives me a list of commands that I might be interested in. They contain BIR. Then if I know the correct command name, I can just run the help command for that, right? You can also look at the examples, right? Display example for command usage, or you can do this R-site search and a bar plot. It's gonna look for the R online manual on this. So see this? This is what it does, and it's gonna use your default browser, whatever your browser have set as a default, right? Okay. Now what we're gonna talk about for your first assignment, for the very first assignment, not assignment but exercise, you are reading data from you're reading iris data that was pre-installed with R. However, you're not going to be limited to analyzing only pre-installed data. You want to be able to read data from saved on your PC, right? So what I did was I created the folder called datasets on my C drive, right? And I saved up some datasets into that folder. So first of all, before we can read the data, we must specify, we must let R know where to look for, right? By default, R will assume that you're reading the data from from the working directory, right? By default, right, there is a default setting for the working directory, but you need to set the working directory to the location where you save the file. So I'm gonna do this set WD command. Set WD command is gonna set the current, it's gonna set the working directory, right? But before I do it, let me see what it's by default. By default, this is the folder, the documents, right? By default, it's a documents folder that it is on my PC here, right? So that's my childhood nickname. See this users, right? My username and the documents. That's where it's gonna be looking at by default. But the files that I'm trying to read is not saved in that folder. Where is it saved? It's saved in this one, right? Datasets folder on my C drive. So I'm gonna just run this command, and that changes the directory where I want R to look at. You type get WD and it's gonna tell you the current working directory, right? And also notice in here in the title bar of this window, you see the current working directory as well. All right. Now what else you can do is suppose that you don't quite remember the file name, or you can do this list files. It's going to tell you which files do you have saved in your folder right here. Suppose that for some reason you're trying to read the file and somehow the command is not working. So you want to check if the file exists, right? That's one way to check if the file exists. And file names are case sensitive in this case because you're running a search, right? So in this case, this is a file, HR data file, it exists. So it's returning true. Again, remember everything is a vector, but here, look, list files. Look at this, the output of this command here is on 3 lines. And what do you see here? Here, this is the index of this element, bank.csv. This one, 4, it means this here is the 4th element, right? And then the 7th element. It's a position of an element, right? Now what we're gonna do, we're gonna read the data from the HR data into the data frame. So data frame, what is it? It's an object where we read the data from the file into it, right? So here I specify the file name. A header equals true. It means that I want to read the column headings from the file. The first line in the file has the column headings. The file is a comma delimited, and this one SE is false because, well, I want to make sure that all of my columns are read correctly. But if you don't put this, it's gonna read incorrectly. It's gonna read the the numeric values of the factor variables are gonna be read incorrectly. So you want to make sure you have this as is set to false. Okay. Now let's read the data here. Okay, so now I've read the data, but how do I know that I actually read anything? Well, first of all, I created the data frame called HR. Well, take a look at this. It's here. It now appears in my environment window, and it tells me how many observations on here. And here is a number of columns. And here I see the list of column names and their corresponding data types, right? So here are the values on each row. Here, notice this. So this is an integer, right? It's number of projects that the person was on. And what is this factor? See this, the department name, it's an accounting, HR, etc., right? It's a categorical column. And the valid values are known in advance, and we know how many, right? Each value is called a level. So, but what does that mean? Like in here, see the salary factor level, 3 levels are high, low, and medium. Number 2 means here that the first record, right, has low value. It's a second value. The second record has 3 value, which is the medium, and etc. It's an index of the values. That's how the structure shows. Okay. Well, suppose that you are using R somewhere else, not in this nice RStudio window. You're just using R. Well, and you don't have this nice interface. So it's always a good idea to know how to do all of this programmatically, right? So we're gonna look at this programmatically also, the structure. But first of all, let's see this. Let's see what's in HR. We're gonna run the command called view, and view is gonna show data in a spreadsheet view. So I'm gonna run this, and it's gonna show data like this. See this? It's like a spreadsheet view, and I can sort it I can sort it by the column and etc. So see, this is the spreadsheet view, and I can filter it if I want to, right, and more. So let's close this out. Okay, now this command is gonna be your friend because sometimes you want to actually preview what does my actual data look like. When you type the head command, it will show you the first 10 rows by default. The default is 10. So see this, I put the data frame name as an input, and then next argument is optional. If I don't specify the number of rows, it's going to show me the first 6 rows. Notice here that it has to do because depending on how many columns I have and depending on how long the column headings are, my output might not fit into one line, right? I'm unable to display the values of all columns in one line. So it's going to wrap. That's what it's doing here. It's wrapping, right? That's what you see here. It's breaking up. Now, so that was just the 6, right? But if I want to see 10, I can specify explicitly that I want 10. Tail command is going to show me last 6, right? Or tail with the number specified, it's going to here be last 10, okay? Now we just looked at the data frame. Well, here what we did view and all of that head tail shows the actual data, but they don't show the data structure, right? You run the str command to see the data structure. And by structure, what do I mean? I mean which columns are in there. And you want to see the data type for each column. Then you want to see the predefined values for the factors, right? Factor variables. Like for example, in here, department, I want to see what the departments are and etc. Right? That's what it is. Now str, right? It's gonna show the structure. A class, it's gonna show the data type that it's a data frame, and is data frame is just a way to check if it's a data frame. Well, sometimes you may have some logic in the code where you're checking if this is a data frame, then do this. If this is not data frame, do that. So that's why sometimes it might be useful, right? There is more than one way to display the column names. You put names command and put the data frame name in parentheses, right? So it's gonna show me the names of all columns in this data set, right? So let me go run this, right? It's a list of column names. Alternatively, I can run column names, right? Next command is to show the dimension. Dimension is basically the size of the data frame, number of columns and number of rows. That's what it did. But again, remember that's a vector, right? So here, this is what? The first element of a vector, it shows me the number of rows, and this is the number of columns, right? There is another way to show the number of rows. I can just do nrow command, and it will show me the number of rows. Or, well, what am I doing here? Remember, what dim command returns, it's a vector of 2 elements. But when I display the first element in here, I'm showing the number of rows, right? I'm showing the number of rows here. To display the number of columns, one way to do it is to use ncol command. It's going to show the number of columns. You may also use the length command, right? Or remember the output from dim command, right? It shows what? The number of rows in the first element, and second element is a number of columns. So that's what I'm doing here, right? Or here you can it's taking the list of column names, and length is going to tell me how long is the list of column names. So that's another way to tell the number of columns, right? So what we looked at right now, we just looked at the structure, right? We looked at the number of rows and etc. But we have not looked at the descriptive statistics yet. Well, what is descriptive statistic? Well, first of all, you know that summary command. Let's run the summary command and see what it returns. Okay, so here it returns the information for each column. Like for example, see the satisfaction. This is a continuous number, right? So for that, it's going to show you minimum, first quartile, median, mean, third quartile, and maximum value. Because that's numeric, right? It's a continuous values. Same is the case for last evaluation and the number of projects the person has been on, and etc. But, well, take a look at this department, right? What is this other? Well, department is a factor. What it's showing here, it showing me the first 1, 2, 3, 4, 5, first 6 actually dominant values, right? So these are 6 dominant values. number of observations that have each value, and these are the remaining values that don't fall into any of these, right? So here again, I'm limited. I was limited to 6, right? But there is a way to fix it. I'll show you. But by default here, it's showing 6, right? 6 values, 6 the most dominant values, and how many instances have that value. Well, this one is the salary. There are only 3 values, right? Salary has only 3 values. Okay, now well, here this is gonna be output here is gonna be a little different. What I did was I said there is a parameter called max sum, so that can tell you it can tell you how it allows you to show more levels in here. Well, see here at a moment I'm only showing what 6 the most dominant ones, right? Departments. But what if I want to see 9? Well, then I need to run this command here. I suppose I need to set max sum equals to 9, right? In this case. So I'm gonna run this. See this? Let's look at it now. It's changed how the output looks like because I said it here, right? I want to see 9. Yeah, so I can even change more if I need to, right? Now, apply command is gonna run the specify command for each. It's gonna see this. It's gonna just do. Oops. Now here lapply command is gonna run the summary command on each column in HR data, right? So let me run this. It's running a summary command for each column, but please note that it looks a little bit different. See this is a department. And for each department, it shows the number of people, and same thing the rest of it, right? Salary, it's gonna show me the number of people at each salary level, and etc. Right? So okay. Next one here is, well, minimum. You know that you can look at the column minimum, right? You can also look at the column range. Range tells you the differences between minimum and between maximum and the minimum, right? So let's see here. We do this. Let's do range. Well, see this? It just gives me. Oh wait, sorry. Range is gonna show me the minimum and the maximum. That's what it's gonna do. It's gonna show the maximum and the minimum. That's what range does. Okay. And this one is a standard deviation that is not displayed by in the summary here. Summary command does not return the standard deviation. But if I want to see the standard deviation, I need to run SD command, okay? Then unique is going to show that if the values are unique in the column and department, right? Here, levels department is just going to show the values that the department can have, because department is a factor, right? So values, it's going to return the list of possible values that it can have. This one is just the aggregation here. So let's run it. This one is looking at the satisfaction level per department. See this? I'm gonna assume that I'm gonna look at the department. See this here? That's what this does. HR satisfaction level department, and this. Okay. Next, we're gonna look at the data subsets. Well, suppose that you have the HR data frame, right? But if you're only interested in a first row and all the columns in it, right? So this is how you would do that. You're gonna run HR command. I'm sorry, you're gonna run. Yeah, here HR is a data frame, right? So you want to output the first 5 rows in HR. Sorry, so this is what you're gonna do, HR, and you're gonna put 1 through 5 in the brackets. So this is what the row number. But here you specify the columns. But if the column name is omitted, it means that you want to show all of them, right? You want to show all of them, all columns, but 5 rows. That's what it's doing here. Because you did not specify what the you did not see here, you did not specify which column to take, so it's going to take all of them, it's going to display all of them, right? Here this is a little bit different. You specify which rows to take and you specify which columns to take. So that one probably worked, right? That one worked without any problems. Now here, this is I'm taking the list of column names, right, and doing 1 through 6. I think this should still work. This still works, yes. I'm taking the list of column names and then I'm looping through the first 5 or 6, right? Well, here, now remember what is C? C is a combined command, so we want to take a subset that takes the first 5 rows, and it's gonna take and it's gonna see this. So let's run it. See this here. I'm gonna show this. See, okay, let me show here. What this does is this. See this? It's showing department and left column, right? Because here what you can do is you can specify the positions of the columns that you want. You may specify the column names too, right? But in here, see this one, it was just 5 rows, 5 columns, right? The first 3 columns. We don't specify the column names. Here it's regardless. Here I specified the 2 column names that I want to take, right? Here I want to take all rows from the department and left columns. So this is all rows, not a good idea to preview. Okay, but what is this, the number of omitted rows? Well, you have a property where you specify how many rows to show. If the result is too large, right? Well, here there is no 1 through 5, but that's going to be a mistake because it's going to look at, see this, that you usually don't do that, right? Because what it does is it's going to display these 2 columns for all records. You probably don't want this. Now, when I do this history 1 through 4, right? Let's run this. Okay, so this is just his HR salary 1 through 4. Sorry. So HR is a data frame, right? Salary is one of the columns in the data frame, right? So you put what data frame name, $, and then put HR, and 1 through 4 is a position, right? Where it's saved. So I'm gonna go ahead and I'm gonna run this one, right? Now what I want to do, I want to return the rows only that satisfy my explicit condition. For example, I want to look at the salary that is medium. See, the salary equals to medium, right? So let's run this. This is a double equal sign, remember? Well, so what I did here, I just outputted the rows for medium, right? I could also say this, where department is HR and salary is medium, right? I can do that. Oops. See that? I could do that too if I wanted to. And then, okay. And then let's run this one here. This is a little bit harder, but what I'm doing here, I'm saying the department should be HR, and then that see here, I wanted to take just the minimum, right? So those are the rows with department HR and salary is medium. That's what it's doing here, okay? Now you could also add another variable, okay? So before we do the thesis, I'm gonna run this thing to display the structure, and I'm gonna run the head R again, right? head HR again. I want to see the first suffix rows now, because just looking at the blank table structure sometimes doesn't make a lot of sense. You also need to look at the data, right? What the data looks like. Now here, see the deleting a variable. Another contractor wrote some reports for the customer that they've been using, right? So here, look, so here what I'm doing, you can add a variable, right? You can add a column or you can delete a column, but how do you add a column? Look, easy. You just put this data frame name, you put column, you put $sign, sorry, and you put a column name, right? And then that's a column name that you want to call the new column. Then in here, you're gonna still repeat your username. Here, time spent with the company is probably how many years have you been using, right? It in this data set, it's for how many years somebody has been working with the company, and multiplied by 12, right? That's what it determines. So now let's see how much months I spent. Let's run this command. Okay. Oh, it's because I did not do the output. Head HR. I have to do head HR. And then so here, this is just I'm just running the command to show. So see this. Oh, okay. This command here, what it will do is it will remove the months spent. Okay. Look. So here I'm adding it, right? I'm adding months spent, and I'm doing this here. I'm multiplying time with the company times 12, right? So that's what I'm doing here. I want to find out the number of months spent in the company, and I take time with the company and multiply by 12. That's what it does here, right? And then I output. Here I'm gonna delete all variables, and then I created a new one. I have this HR data frame, and the data frame has this here. See this? So okay, so let's see. I'm gonna run this. It's a data frame, right? So see this? I have a new column. So how do I know that I have a new column? Well, I can do the head, right? So this is a head command, and I'm gonna see month spent, right? Month spent with a company. So see, now I know that I added, but this is opposite operation. It will remove. To remove, you just put HR and then you put the $sign and you put the column name and you set it to null. This is how you delete it, okay? To delete the column, you just set it to null. Well, it's the easiest way to do that. Now, sometimes you might be wondering why we would be deleting the columns, right? Well, if you have a column that is a key, right? Like for example, just the key, individual number, the number is started from 1 and continues, right? You probably don't want to use somebody's unique number as part of the analysis, right? It's not gonna give you so much insights, okay? Another reason is that if you have something it's called PII, right? Personal information that should not be given out. For example, your data may contain a column with names, right? Which are what? Confidential. You don't want, Jesus, you don't want to use people names for your analysis, or they could be the last 4 digits of the social security number, something like that, right? So that's one reason for deleting the column. So here it is. The easiest way to delete it is what? To set it to null. Next thing is sorting. Why do you care to sort? Well, sometimes perhaps I want to identify the top 5, right? So then I need to sort it and select the top 5, right? So I have to sort this. Sorting could also be used to identify the duplicates, depending on how many depending on the size of your data set, right? Now, here what I'm going to do, I'm going to create a new data frame called HR sorted. So what is it doing here? It's taking all columns, but for the rows, it's going to try to sort by the satisfaction level. Okay, so let me see. I'm going to run this, and then I'm going to see the head here, right? Well, you always want to make sure that you have not damaged anything, right? So this is the sorting, and this is it's taking the satisfaction level. It's another group because this username appears on on a two groups, right? So I'm sharing it with each group. So now here this is sorted, right? I can try the get command. Let's what happens. Run, run. Okay. So what I did, so see here this one, what it did was this does the sorting, right? So let's see. HR sorted, I created that, and now I'm gonna look for the first 10, okay? So and what am I sorting it by? Satisfaction level. And I can specify if I want to do ascending or descending, and I can also search for what? Search by multiple columns, right? This one it just shows the first 10, right? So this one I can sort the descending, but to sort the descending, uh, you would need to put the minus sign here, and this is the column name. So I want people to use my user V, right? The username is V for it, and they want to use it while I'm doing my assignment here. So that's possible. You just know their user, right? It is here. So you can. So that basically was the sort, right? So let me see here. This one returns the result, and this is another one, right? Where I'm sorting by the two columns. Is this the satisfaction level and number of projects, right? So I'm sorting that and sorting back to return, right? So you have to be, if you, perhaps if you help somebody with this command, right? If you went in somebody, you join somebody's another player's shop to help with the command, right? Just an example. If you are like working, okay, look, let me see. Like sometimes, okay, look here. So you run the sorting by column, right? And you do this. See this? So this is sorting by the two, right? So sometimes, like for example, you want to look at the satisfaction level, how satisfied the person was while working, right? But for the employer, not for the employer, right? So you want to sort by satisfaction level, but the problem is sometimes you can have multiple rows with the same value, right? So you want to add another one, you want to also sort by the project. So that's what it's doing here, okay? Now here, this is just gonna show the top 10. Okay? Okay, now here, this is a factor. This will convert the attrition to a factor. What is this? Well, the left column it sorts when a person stayed or left, right? But the problem is the values of the column are 0 or 1, right? But if you look at what summary was doing to the column, it was calculating the minimum, maximum, and etc. Right? Like if you run the summary command on this, right? Let me run the summary right now. Take a look at this. How is it possible? Can you stay 100%? Or well, you either stayed or left, right? You cannot be like half left. You cannot be half left the job. Okay? So this is actually meant to be a factor. So what you do, this is the factor command, you convert it, right? And you set it to itself. You assign it to itself. So now this is what I want to see, right? Is a factor 2. Okay. Now this will show the frequency count, and this will show the proportion of the frequency count, and this is a cross tabulation, right? So here I'm looking at the salary and what is the person left, right? So for example, I see somebody, you have 1,155 people with a high salary to state, right? And here, this is how many left. So, well, if you look at this, if we were doing some analysis, you could see that somehow the salary could have some impact on whether a person left or stayed, right? So this is just the frequency. Oh, another thing is that if you look at how the data looks like, you may have noticed that there's some missing values. Or even if you go back and look at if you go back up, if you look at the summary command, you're gonna see something that says NA. I may need to rerun it, right? So if I just do the summary, oops. If I just do the summary, take a look at that. It says NA. Next to some of these NAs, what is NA? NA is a missing value, right? Null or basically NA, unknown, non-specified. There is no value. Okay. Why is no value a problem? Well, let's take a look. Let's take a look at this last evaluation. This is when somebody had a last evaluation, right? So let's take a look at this. I want to take the mean of this column. Do you see the problem? Why am I getting an A? It's because I'm trying to find the mean value of a column that contains missing values. See, that's why I'm getting an A. But I have missing values, but why can't I just skip those rows and do the mean for the rest of the rows? Okay, there is an option and ARM equals true. This will explicitly ignore the rows that have a missing value, and it will complete this calculation for me, right? It just ignores the rows where the value is not specified. Now, suppose that you have a data set you need to work with. How are you going to check if the data has any missing values? Suppose it's a huge data set, there are thousands of records. Are you going to scroll through the whole data set to see if there are any missing values? Are you going to be done on time by the time the work is due? I don't think so, right? So, well, here, any command returns if the data has any missing values, but is NA. What does is NA do? It will return if the element value is missing, right? So is NaHR, if I just run this piece here, it's going to look at each element with HR file, and it will return false if it's not missing, and true if it's missing, right? Any is just going to take a sum, right? It's going to tell me how many elements are missing a value, right? Well, true, it returns true. It means that there is only at least one, right? If it returns true, right, any returns true, right, then it means that there is only one, but I need to know how many. So I'm going to do the sum. See this sum, it's going to tell me how many are missing a value, and any is going to return if there is something missing a value. And this one is this, here I'm just looking at the specific column. there is one missing value in that column, but I want to know which element is missing, right? So now I know that this is the row number 375, right? And it's missing a value for the last evaluation. Okay, so this is just one way to show. Here, I want to see the observations that are incomplete, right? Well, this is complete and this is a negation, right? So I want to check which observations are incomplete. Incomplete means what? Have at least one missing value. Remember, there are two rows that missing a value, and here we go, right? These two rows are missing a value. Now, I know that I have a column that is missing values. How can I find out how many instances are missing value for that column? Well, this is what you're gonna do. You're gonna run this call sums, right? You're gonna run this. It's gonna show you how many instances are missing a value for each variable, right? So that you will do that. So you know that, see? For each column, how many rows are missing a value, right? So that way you don't need to run the command above separately, right? I just did it once. See this? I'm looking at all columns. I don't need to run it one column at a time. If I want to know for all columns, right, how many rows are missing the value. Now that's what it did. Okay, next one is how can we handle missing values? Well, first of all, we can remove the row that has missing values. For example, here I want to create a new HR, but then I'm going to take the HR and I omit means I want to omit the rows that have missing values. That's what I'm doing here. Or I can also do it this way, complete cases, right? I can do complete cases command. Get that right? Now, I suppose that, well, removing rows could be a danger because I could be losing my valuable data, right? Sometimes you want to set the missing values to the column average, right? So how do you do that? Well, first of all, you need to find out what the average is. So here it is. But to calculate the average, you need to ignore the missing values in that column, right? So that's why you see NARM equals true. So this piece is going to return the column average. This here is going to take, well, it's going to look at which rows, right? Which rows are missing, which observations are missing, the value for that column. Where is it NA, right? And then take that wherever it is NA and set it to the column average. This is just for that column. Here, I'm also making a business decision here. And I say if average monthly hours are not specified, I want to use 200. So that's another way. I can make up a value. I can assume, right? Like for example, sometimes it could be a column that calculates number of children, right? And if the value is not specified, I can decide to treat it as unknown, something like that. That's what I'm doing here. So basically, to handle missing values, you can remove the observations, right? That miss value, but you could also replace the missing value with a column average, right? You can do that, or you can replace it with a certain predefined value. Like for example, if it's missing, I can say something like unknown, unavailable, I want to use some kind of like a value as a placeholder, right? I can do that. Now here, this is just shows the summary command. This just shows the summary command again. Well, because what we need to do is we need to verify that we are getting what is expected, right? So basically, I would just check the column properties before and then check the column after, right? Okay, so here it's just gonna check how many columns. See that it's gonna check for each column. It's gonna check if there is at least one value missing. But I handled just one. I didn't handle all of them. Did I run this? I don't think so. Let's run this. Okay. And then you just do that. Okay. And now next thing that we're gonna get to is installing and loading packages. Packages are functionalities. You have a lot of packages that are installed with R, but not all. When you start, actually even this week, you'll be doing discretization, and you have to use a rules package for that. So you will need to install it because it's not installed, right? When you install the RStudio. But how do you know what do you have, right? Library, it's gonna show you the list of installed packages, right? So you have the list of the installed packages. That's what library does. Now, search, it's gonna tell you which packages are loaded in memory right now. Because if package is installed, it does not mean that it's available. It's not available until you actually put it in a memory, okay? Well, this is just URL that you can use to look at the available CRAN packages. Oh, here, pass, our library pass is just gonna show you the locations in the system where it's saving the libraries, right? In this case, you have two locations. One location is a system library, and another location is a user library. So system is what was pre-installed when you installed R, and user library is what you got, okay? Well, here, this is what you would run. I don't need to run it because I already have it installed, but install packages command will install the package. You have to have a rules package for the discretization. Well, you have two exercises, right, for this bi-week. The second exercise requires you installing the package because here you'll be doing the discretization, so you have to install the package there. Now, require and library, those two commands are the ways to load the package in memory. Like suppose that I'm ready to work on discretization. I need to run the library command, right? Or require command, either of this. You want to load the package to memory, but wait a minute, I got an error. Why did I get an error? Because, oh, I need to install the package or rules. Sorry, okay, I'll tell you what happened. Recently, there was an upgrade to an R version, right? And sometimes when you change, depending on if it's a patch, right? Depending on how big upgrade is, R creates a new folder for user libraries, right? So that's why it was not finding it. So now I uploaded it again, right? Remember we were looking at there is a folder on my PC where I have this library stored, right? So we've got to version R4.2. So see this is a structure, right? See this, it's a structure. For this 4.2, this is a R version, main version number, right? So see here, it says it downloaded the packages, right? It downloaded the packages. So packages there, but it's not available because you have to install, you have to put it in a memory. So you run it either require command, or you can run it the library command. Now, well, what you see here, this is in red, but it's not an error. Just remember that not everything in red is an error. this is just a message. It's showing you that it loaded the package called rules in the memory, but the problem is the package has some functions with the same name as some function in this base package. This is just a warning. It's gonna tell you here that the rules, right? The package that you installed, the function in the package that you installed will be more likely called, right? If, well, suppose that the package that you, so what it just loaded in memory is that package may have functions with the same name as functions in other packages, right? But here in this case, when you call the function, well, you can always qualify the function name with a package name, right? But in general, what it's saying here, objects are masked. So it means that it's gonna, if whatever you're trying to do appears in the rules package, it's gonna go call it first, right? So now either library or require, you can load the package in memory. Okay. Now, and I just showed you I installed the rules package here, right? Now here you can learn, you can open the package documentation page, right? So how do we do this? Let's see, let's run this. Jesus of this will open up the documentation page for a rules wish. And here it just gonna shows you this is called the VNet. Well, VNet is a package usage example, right? So it can open that, right? So I know that some packages do, they have it. Nice examples on how the package is being used. Oh, see this? This is a VNet for this. See? Okay, now let's close this. Oops, what did I do? Oh, here it is now. We're good, right? Now here, well, take a look at this. The packages are being updated all the time, right? So what this command will do here, it will get the latest version of all packages that you installed. That's what it will do, right? Once in a while, what I do is I just either run this command or I just go here. Well, and there is an option to update here, and it will show you what needs to be updated, if anything, right? Another thing is that, well, you have a lot of packages loaded in memory, and at some point you determine that you don't need some of them. Detach command, it's gonna unload the package. The package still remains installed, but it does not, it's not in your memory, right? So this will detach will do. Detach, remove from the memory. Then this one, I'm not gonna run it, but this will delete the package, permanently remove the package, okay? And now, next thing is data visualization, right? Well, what you are asked to do, well, you have the little exercise, right, on iris data, and the iris data exercise has some examples of the visualization command, right? But here in this case, this is the histogram command, right? So AIHST, right? And this is a column that I want to build the histogram on. And what is this? The histograms are for numeric columns, and it's gonna show the frequency. So let's run it. Well, but if I give you hands-on test, perhaps, right, or anything, if I ask you to display the histogram, you're not limited to the default stuff here, right? So what you could do, in addition to just specifying the name of the column, you can specify, you can want to aim to perhaps 20 breaks, right? To see that, you can do that. You can also change the border color, right? You can change the colors. See, that's a border color. You can change the actual color, right? Well, and also you can do multiple things. You can change the density, you can change the angle, you can change the brakes, well, and etc. And what this will do, the X lab is going to change what you see for the X-axis, right? Well, see, this is changing the X-axis label. So you've got X-axis label, Y-axis label, and just for fun, try it, right? And it will help your quiz too. See, try to read the help system for this command and see which option can be used to change the plot title. So see this, I'm going to try this, right? So this will open up the help page for this histogram command. Well, here, now what you can do is you can read through these parameters, right? And you can tell me, or you will have to tell it, if you receive this question on a quiz, you may or may not, but the quiz might have a question on which options of the histogram command do you use to display the title, right? Well, if you're not sure, what you're going to do is, look, when you're taking the quiz, nobody stops you from running RStudio, right? So, okay, it tells me which option. How do I see what options the command has? I can just look at the help here, right? And then I can see, I see it. This is what I need to do to display the title, right? Okay. So here it is, right? You can make multiple changes. That's what I was saying. And that's just a single example for the histogram here, right? This one is interesting too. It shows the shading, right? Now, well, but the thing is, there are more. This bar plot, it also is going to build the frequency. This will actually build the frequency table for the specified input, right? So what I'm doing right now, I'm just storing it. I'm creating the frequencies for the salary, right? And then in here, I just want to see, so this is a frequency, right? For the salary. Bar plot takes the frequency table as an input, okay? So I store this table into this variable, and now I'm gonna use that, right? So this is a bar plot, okay? Now here, again, am I limited to what I see now? No, I can do the sorting, right? Why not? I can just show first the less frequent, more frequent, and then more frequent. Okay, I can make it horizontal, or I could also change the sortings, right? I can specify how to sort it, ascending or descending, right? Now another plot to show the categorical column distribution is a pie chart. But take a look at this. Let me run it first now, right? Well, here you only have 3 values. So far, so good. Nice and easy, very easy to read. I can see all of my values, right? But there's a problem with the pie chart. What happens if I have 100 of these values? This becomes what? Cluttered and hard to read. In this case, what you would need to do is probably the bar plot is a better option. Y chart works very well when you don't have like a lot of values, right? You want to see the relative frequency. And if you search through the help system, you might be able to find out how to show percentages as well, right? You would need to just play around with the help system, okay? Well, here, this one, box plot is for numeric columns, right? So that's a box plot, you can do that. Well, there is also the generic plot function, but what it does depends on the data type of the column that you're trying to put in, right? That's a pairwise plot, and that will show you the, let me see. So this is a numeric variable, right? Well, it does not really help much, right? and this is two numeric variable. Well, I'm just showing you that this exists, okay? Just keep that in mind that this exists. Now, I talked a lot, I guess, huh? Well, but what you will need to do is you have a couple exercises, do them first and then do the quiz. Because the quiz has questions on exercises, on the output or anything that's being done in the exercise itself. But I'm gonna give you a little hint. Do not forget about the iris data, because that iris data will reappear later in the course. In the later quizzes, right? When you get to decision trees, I believe there will be some questions, like for example, it's gonna give you the decision tree for the iris data. And the question could be involve the result interpretation, something like that. Well, but for this one, for this specific quiz, you have 3 attempts, right? 3 attempts total. There is no time limit, but that's what you want to be aware of. There is a question pool with 40 questions. And when you actually get the quiz, it randomly pulls the 20 questions out of 40. And for each question, the answer choices appear random. So if your friend took the quiz, right? Your friend took a quiz and your friend selected answer A on question 1, answer C on question 2, and your friend tries to tell you the answer choices, it's gonna be wrong. Don't do this, I'm telling you, because, well, first of all, your questions could be different. They could be in a different order. And also the answer choices are in random order. So that way it's very hard to cheat. It's to make sure that you learn, okay? But when you retake it, even if you get the same question, the answer choices could be in a different order. So do not try to memorize the letter of an answer. Focus on an answer, okay? Also, if you get the question wrong, it does not give you the right, it doesn't tell you what the right answer is. But wait a minute, you know which answer choice is wrong, right? And another thing to watch out is that on some questions, it says to select 2 answers. How many of you cannot count until 2? Everybody can, right? So if it says to choose 2 answers, you select only one, regardless what your answer is wrong. Because if it says select 2, you must select 2, and both must be correct to get credit for that question. Okay? I hope it helps. Okay? But now I'm gonna give you guys turn. Do you have any questions on R or anything that we talked about? Maybe any tips on how to survive the course? I can give you the two because I was a student, right? I was in your position before. So anything that you think might help you. It's your opportunity, and I love when students ask questions, and I love students who ask questions, right? Remember me from earlier coursework you took? So, I mean, I'm giving you the opportunity. You may type your question, or you may also, at this point, you may also unmute yourself if you want to say it. No? No questions? Well, please don't feel shy. I hope everybody is still here. I hope everybody is still awake. Now, so what's gonna happen is you're gonna get the recording, and you may still consider watching it, even if you were able to attend the session. Sometimes when you watch the recording again or parts of the recording again, it helps you understand it better. Okay. Oh, and also just to make sure, because what I did was when I went mostly just by hands-on. I did not go with the slides. So I usually sometimes I just look through to make sure that I showed you all, right? Oh, another thing is that I showed you how to use the command, how to look at help pages programmatically, but you also have that little search thing where you can search, right? You can actually also run the search. You see here, I'm on a help page. I can also search for the help commands that I want to. I can also look for help page this way too, right? Well, do you see this? Like this is example help page for the histogram. What it does, it shows me the package, where it's in? It's in the graphics. Okay, so here are the different arguments that it can take, right? And then here is the details. Then there are some examples that you can run, but these examples were on some of them are on a pre-installed data set. There is a set of data sets that were pre-installed, right? And the commands are on them. Okay, so that's basically what I was saying. Well, you've got a nice command history. Oh, and what I forgot to show you about the history window is this. So see, this is a history window. You can clear it, or you can clear only certain command from the history. Well, look here, when you click on a broom, it will clear all history. And then this one here will remove the selected command only. Then I can rerun the command from the history. To rerun the command from the history, I just highlight it, and when I click it to console, it will go to the console window, right? And I can rerun it. And if I click it to source, the command is going to go to my file with the code. Another thing is that when I place my cursor, I can use up and down arrow to browse to the history, right? I can use an up and down arrow. That's another, right? Okay, next thing is this. Oh, look, environment, right? If you look at the environment, you can toggle between list and grid view. Well, see here, if I'm in a grid view, I can see how much space each object takes. And I can also remove one object at a time. This is I ran rm command, but you can also do this, and then you've got this, you may use the broom, right, to remove this. See this, oh, this will clear all objects from the workspace, right? Or I can just do, if I wanted to, I can just do one at a time too, right? But here, see this, it shows you the size. Well, this is something that that view does not tell. Like if I go back, right? This is a grid view. List view does not tell me the size, okay? It's just an alternative way to look at this. Okay, next thing. Okay, so I showed you how to do that. I showed you working directory. I just spelled it out. But, well, you can also go to the global settings, right? And you can change the directory in there too. That's another way. Go into the global setting options. But to be honest, I would rather do things programmatically, because if this is something that I need to do every time, right, when I need to run specific code, then I could add that commands in my code. I don't need to remember to do it, right? So the thing is, well, here it just shows how to read data from the file, right, from the CSV file. It just details user data frame structure. That's basically what we looked at. But what I did was I added my notes for you, so that way you'll have it, right? You have something in writing. And here it explains why you want to sort. I want to find the duplicates, and I want to identify top 10, something like that, right? I want to identify bottom 10. How are you going to do it? Yes, of course, you have to sort it, right? You can sort ascending or descending. You can sort by multiple columns. Well, those are just about the factor variables, right? Well, here it just spells out things about the missing values, right? Well, because you have to, I don't remember if you have to do anything, or well, you may encounter times when you have to handle them for assignment, right? Uh, well, okay. This is on the packages, right? Before, RStudio used to have the two sections. It used to show user library, the packages that you installed, and then the system library, the section of these packages that were pre-installed. But right now, for some reason, it does not split into sections. Okay. Well, those are the useful commands for the packages, right? Another thing is you want to remember package name is case sensitive. So if there is a package name Yelena that starts with uppercase Y, it's not the same as package name Yelena that starts with lowercase y. See, it's R is case sensitive. Remember that, right? Well, here I just explained for you when to use each visualization. For some of them, then this there is a cognitive path side with some of the self-paced courses. It's after this course is over. If you're interested to learn R more in depth, those are some of the stuff that you can do, right? This is like extra stuff to learn more in depth. But R is you're gonna revisit R when you take the data 650, which is big data. You're gonna see R again, more advanced, okay? Then if you go, well, if you go to the LinkedIn, there are some groups that you may join, some R groups that you might find some interesting news and etc. Once in a while, it's good to read stuff. And here are some additional sites that you might be interested in, right? Well, I had to put some references, right? Because the information that I presented was not out of my head. So always, put some references for you. Okay. Any questions that you think may have come up? Everybody is so quiet. Did they scare you? I usually don't, right? So any questions that came up? Because I was talking for an hour and a half. So now I want to spend a little bit of time listening to questions and answering them. No? No questions? Okay. If there are no questions, that we're gonna call it a night. And I want to wish everybody good luck. Enjoy Data 630 course, and hopefully everybody does well. Just enjoy and okay, and have a nice evening as well. Okay, I'm gonna stop. Oh wait, I have something. Oh, just a thank you. Okay, no problem. No problem. I love doing it. I enjoy doing these sessions. Okay, so I'm gonna stop sharing and I'm gonna stop the recording, and I'm gonna send the recording to your professor. Okay, stop recording.